Okay. Apply null factor law to solve quadratic equations. So, first thing, what is null factor law? Okay, well, if I say a times b equals 0, oh, we don't know what a and b are, but can we say anything about them given when I multiply them, they equal 0? Hopefully you can say, well, at least one of them has to be 0, because that's the only way you can have them multiply out to give 0. So, therefore, one of the following must be true. Either a equals 0, or b equals 0, or both of those are true. Now, since we don't know, right, we're going to say, okay, either this is true or this is true, and we're going to imply that both of those could be true at the same time. Because if they're both 0, 0 times 0 is 0, that also works. Okay, fine. Well, that's what null factor law is. It's just saying that if you have a bunch of things multiplied together, at least one of them must be 0. Alright, well, what if I've got something like this? I've got something multiplied by something equals 0. Well, we can use the same line of logic. Okay, that means that x plus 2 must equal 0, or x plus 4, x minus 4 rather, must equal 0, or both. Well, okay, what if this is true? Well, if this is true, we know how to solve that. Just minus 2 gives me minus 2. Add 4 for that one. So I get that. So, in order to make this equation true, either x is negative 2, so I put negative 2 into this, I get 0 here, and then negative 2 in this is giving me negative 6, but I don't care because 0 times anything is 0. Great. If I put in 4 instead, when I put that into there, that'll make this 0. That'll make that positive 6, but I don't care because 6 times 0, 0. So long as at least one of those is true, then this equation will hold true. And if both are true, then it's definitely true because then I end up with 0 times 0. However, x can't simultaneously be negative 2 and 4 for what we're looking at currently. So we say x equals negative 2 or x equals 4. We can't simultaneously have the same variable being both at the same time. Cool, okay. Well, let's look at quadratics now, because we want to apply this to solve quadratics. So here's a quadratic. This quadratic equals 0. Okay, well, what do I do with quadratics when I see them in this form? Almost always it's a good idea to factorise. Okay, well, x plus 2 things at times to 5 and add to 6, 5 and 1. So I get that. Brilliant. Well, look at that. It's almost as though we did all this factorising for a reason. This times this, well now it's looking a lot like that guy. Okay, so either x plus 1 equals 0, or x plus 5 equals 0. Go, solve that. That must be x is negative 1, or x is negative 5. So, if I go back to this and I put in negative 1 to check, okay, negative 1 squared, that would be positive 1, negative times negative positive. 6 times negative 1 would be negative 6, and 5. So I've got 1, 5 gives me 6, and negative 6 gives me 0. Yep, that checks out. Negative 5 squared would be positive 25. Add another 5 would be 30. Negative 5 times 6 would be negative 30. So add those together, I get 0 back. So that definitely checks out. So just like always, you can sub your results back in to check that it actually works. Cool. Okay, well, what if we go to this guy? Okay, well, I've got a trinomial again, so 2 things that times to the end, add to the middle. 2 things that times to negative 20, and add to 8. Well, what times to negative 20? Well, I've got 4 and 5, but that doesn't give me an 8. 2 and 10? Oh, well, hang on. 2 and 10 can give me an 8 if I mix them the right way. So, 8 plus 2, x plus 2, x minus 10. Sorry. There we go. Cool, okay, well, now we're back in this realm again. So, either x plus 2 equals 0, or x minus 10 equals 0. Okay, well, that means x is negative 2, or x is 10. Beautiful. Okay. Now, there's one little thing that I want to do just to point it out. When you get to here, you can just look at that and go, oh, hang on. This thing is the negative of this thing is the negative of that. Similar story, this and this, This guy is the negative of that. This guy is the negative of that. I'll get rid of the x. So these things just end up being the negatives of each other. So you can actually just factorise it and then jump immediately to solutions if you want. So long as these are exactly in this form. And similar story up here, plus 2, minus 4, plus 4. So they're always the negative of each other. Cool, that's fine. Alright, well now we've got one of these. Well, that's a little bit different. What's going on here? Well, if we go back to old school stuff, now we go, okay, well, I've got a quadratic. Okay, well, what I want to do is factorise it. Well, okay, go through your list. Hang on, common is the first thing. Is there anything in common? Yeah, there's x's in common. So even though we haven't done common perhaps in a little bit, when we're now into solving, things can come up in any order potentially. Cool, so now I've got this and this. Well, this doesn't quite look like these things unless I just put brackets around it. If I put brackets around it, I just go, okay, this bracket equals 0 or this bracket equals 0. Well then, x equals 0 or x equals positive 5. Brilliant. Cool. I've got this guy. Well, what's going on here? Well, as always, go through your list. Can I do anything in common? 3 and 48. Yeah, they both divide by 3. So I can take out a 3 before I do anything else. And 16. That looks different again. That should be an equals. Minus, that's better. That's a square minus a square. Difference of 2 squares. So I've got this 3 still out the front. X plus 4, x minus 4. Great. Hang on. Well, I can just run straight away and say, oh, that's the negative of this, or the negative of that, which is the positive of it. Okay. What happened to this 3? Well, if we think about this for a second, 3 times something equals 0. Well, it doesn't matter if I do 3 times 0, it will always be 0. So I can essentially ignore this when I'm solving. Another way of thinking about it is if you take this and then divide everything by 3, okay, divided by 3 cancels, 0 divided by 3, 0. So if I just go like that, well, this divided by 3 doesn't do anything anyway, so I can essentially ignore that 3. Okay, great. Well, what about this sort of thing? Well, we can look at it and go, well, 2, 12, 8, hopefully we recognise immediately, I can take a 2 out of the front of everything. Cool, okay, what are we going to do from there? Well, is there anything else in common? No, and now we've got a trinomial, so recognition. 2 things that times to 4 and add to 6. Do such numbers exist? No, I don't have any of that. Alright, what's next? Hopefully completing the square comes to mind. Open up square brackets here. Cool, half that. Plus, yeah, you can do plus k, and I'll let you do this on your own since we've already got other videos for it. But eventually you should end up with minus 5. When it's all said and done. Great. Well, this looks totally different to these guys now. What are we going to do? Well, similar to this, first thing we can do is divide by 2. Well, divide by 2, that's over 2. Alright, well, that does nothing. It's still equal to 0. So now I've got everything in the brackets equals 0. Well, hang on, these brackets aren't doing anything anymore. So I can say, oh, great, I will, I'll add 5 to both sides. Okay, well, I add 5 to both sides, I get x plus 3. That's terrible 3. X plus 3 equals 5. Okay, now what? Well, hang on, I've only got a single x floating around. I can solve this in the super old way now. Great, so what do? I'm going to take the square root of both sides. Get rid of this here squared, so I get x plus 3 equals, now, when I take the square root, remember, plus minus. Now I don't have to put plus minus on this side because that plus minus takes care of it, is the short version of that. Cool, so I've got this and this, great. I want the x by itself, so I'm going to take off that 3. X equals negative 3 plus minus root 5. You can write plus minus root 5 minus 3, but typically you put the normal numbers first and then the surds afterward. That just tends to be convention. It's just so that this plus minus reads a little bit better. You can do it the other way, but people look at you funny. But it's up to you. You can do it the other way. Beautiful. So we get some terrible number. Well, no wonder we couldn't look at this and factorise it. Had this terrible solution involved. Okay, fine. Well, what about this guy? Okay, well, we look for a common factor, 15, 38, 24. Nothing in common there. Well, we have to do bury then. So, I've got 15 by 24. Oh, geez, this is getting a bit tricky, but I'll let you guys figure this out. But eventually, this whole thing factorises to that, I think. Yep. Okay, so eventually that factorises there. If you're not sure how I got from here to here, then you've got to go back and look for the video on Berry method. You don't just look at it and solve it, it's a bit of work. I'm just shortcutting so I don't run out of board space. Okay, great. So I've got this times this equals 0. Well, that's a bit chunky because I can't just look at this and solve it now, because it's not just x plus or minus something. I've got 3x plus or minus something and 5x plus or minus something. So what we're going to do, well, we're going to say, all right, this has to equal 0, or this has to equal 0. Okay, great. Well, solve this as normal. 3x equals negative 4. X equals negative 4 divided by 3. Or 5x equals negative 6. X equals negative 6 on 5. Cool. Beautiful. So x is negative 4/3 or x is negative 6/5. Beautiful. Fine. So what you're probably noticing is the deeper we go, the more annoying the results can get. Well, maybe they're more annoying, but we can actually resolve them, which is half the battle. Okay. Great. Well, now go with this. X squared equals 4x minus 3. Well, there's something a little bit different about this to the rest of them. Hopefully you can see that at a glance. All my other ones beforehand already equaled 0. Well, in order to use null factor law, we need something times something equals 0. I don't have an equals 0 anywhere in here. That's going to make life difficult. But let's just shuffle this around to make life easy for ourselves. We'll make it equal 0. So we'll just move everything to the left side. So I've minus 4x and added 3. Okay, beautiful. Now, why did I do that and not, say, move the x squared to the other side? The only reason I moved to the left was because I wanted the x squared to be positive. So move it to whichever side makes your x squared positive. You can do it both ways, but typically you want to avoid negatives in front of your first term. Okay, so we've got this. Great. Well, do we know how to factorise this? Two things that times to positive 3 and add to negative 4 would be x minus 1, x minus 3. Cool, solve as normal. So x is 1, or x equals 3. Beautiful. And I can move this up, it turns out. Minus 5, minus 6, minus 5, minus 6, minus 5, minus 6, minus 5, minus 6. Okay, that's supposed to be 5. Cool. We're going to do that one last. Okay, what about if we've got something like this? Well, we can move that so that it's all on the left, equaling 20, and that's usually a very good idea. So we'll do that first. Cool, great. Well, now what can we do? Well, we could divide everything by 5. Okay, so divide by 5, divide by 5. Where's my blue? There it is. Cool, gives me negative 4x equals 0 still. Cool, now you might be tempted to say, oh, we could divide by x. Do not do this. Do not. Okay, now the reason we're going to say don't do that, we'll do it, and then I'm going to erase it so that you don't have that on your final version. Let's say we divide by x. Alright, x squared divided by x would give me x. Negative 4x would give me 4. Cool, well that looks like x equals 4. Now that's all well and good, but take a moment to go back to this and say if x equals 0, what does this do? Well, 5 times 0 squared is 0, 20 times 0 is 0. So x could equal 0 as well, that works. But that didn't come out in our answer. That's a massive problem. So we need to think a little bit more carefully. We made a boo-boo. Never divide by x when you're trying to solve. Instead, here's how we're going to think about it. I've got a quadratic here. Alright, well, I should factorise it. What's in common? X. So rather than dividing by x, I just bring x out the front, x minus 4. Beautiful. From here, I can put brackets around this, that's fine. So x equals 0 or x equals 4. Beautiful. So now we've got both potential solutions in there. Cool. Alright, well, what about this thing? This is looking very different. Well, we're trying to solve these, so whenever you're trying to solve, shove everything on one side. Okay, well, let's shove everything on one side. We get x, we'll say plus 5 on x plus 6 equals 0. Okay, well now what are we going to do? What's the most annoying thing? This divide by x is really annoying, so we'll multiply everything by x. Now, that has its own potential problems, but we'll get there. So we're timesing everything by x. Cool. X by x, x squared. 5 divided by x times by x. These two should cancel each other, so we should get a 5, which I'm actually going to write over here. And then 6 times x, 6x. 0 times x, 0. Now I've just switched the order of those. It doesn't actually matter because if you're adding values, if you switch the order of the values, it doesn't matter. So now I've got x squared plus 6x plus 5. Brilliant. We already know how to solve that. We already did it back here. Right, so it goes into something easier. So just because you've got some weird divide by x or some other weird combination of things doesn't mean you should immediately just give up and cry. It means you should just try something out, move stuff around. You'll be surprised how often just moving one or two things to the other side can suddenly make you look at it in a totally different way. Cool, so that's that. That's all of the solving of quadratics on the sheet. We haven't done quadratic formula yet though, that's the next one. Cool. You have to have all of your factorising down pat, so if you haven't done all of the factorising stuff, make sure you're good and strong with that before you tackle this, because you have to factorise all the way through this, and it's just going to keep changing which way to factorise as you go through. Cool. Best of luck to you. Cheerio.